All right, hello everybody. So today we'll be continuing our discussion on adding and subtracting polynomials. So I just want to go through some more complicated examples that involves more than two polynomials as well. So let's get going. So just some review from yesterday on what is a polynomial. Like I said, it's a mathematical expression that consists of variables and coefficients that involve addition, subtraction, multiplication, and non-negative integer exponentiation of variables. Here we have some examples of a polynomial. So we looked at adding and subtracting polynomials and the step-by-step process in adding and subtracting polynomials. So for more than two polynomials, this step-by-step process for adding them, for adding more than two polynomials will be the exact same. You would just, of course, remove the brackets from each individual polynomial, so all of the polynomials. But in terms of subtracting, we have to, in step one, we have to flip the signs of all the terms in all of the brackets, except for the first one. And then, again, we're adding the polynomials together. So I'll be getting through the examples soon. I just want to do one quick reminder. When we're adding a negative term, that simply means that we're subtracting that. We're subtracting the term. So for example, if I have 8 plus negative 4, that's the same thing as saying 8 minus 4. Because a plus and a minus always makes a negative. And again, this applies to if we have multiple negative terms in a bracket that we're adding. Then this rule also applies. So example, if we're adding 18 plus bracket negative 4 minus 2 minus 3, and then close the bracket, we have 18 plus negative 4 plus negative 2 plus negative 3. Again, a plus and a minus is the same thing as saying minus. So it's going to be 18 minus 4 minus 2 minus 3, which is equal to 9. So I just want you to keep that in mind as we go through the examples, which we'll be getting to right now. I will be switching into my document camera. Okay, let me do full screen this time. Okay. Oh, that's not working. Oh, there we go. Okay, so here we got two polynomials. We got 8a minus 4a squared minus 7 a cubed minus a. So let's do this simple example first. So we're subtracting these two polynomials. So what that means is we have to flip. Each term. Flip the signs of each term. Okay? And then once we flip the sign of each term inside the bracket, we can add the new flipped polynomial to the first polynomial. So let's flip the signs. Here we got negative 7a cubed, which is, when I say cubed, I mean a to the power of 3. That's a fancy mathematical way of saying a to the power of 3 is a cubed. So we flip the signs because the sign of 7a cubed was positive. Sign of a is negative, so we have to flip that, so it's going to be positive a. We're just taking the opposite. Now we have to add these two polynomials together using the step-by-step adding a polynomial process. So we have to first drop the bracket. So we get 8a minus 4a squared plus, this is what I was talking about for the reminder. So if we have plus negative 7a cubed and then plus a. So plus and a negative just means negative. So we got 8a minus 4a squared minus 7a cubed plus a. Okay, hopefully that makes sense. But if you have a question about this step, please do include it in the chat. I'd be happy to answer. Okay, so now we need to collect like terms now. We need to collect like terms. So remember that a like term is a term that has the same variable raised to the same exponent, but not necessarily the same coefficient. So for example, 8a and a are like terms. And then we add the like terms together. So 8a plus a is equal to 9a. because we have to add the coefficients together. And then we're including the variable. So 8a plus a is equal to 9a. So that takes care of these two. Does 4a squared have a like term? No. 4a squared doesn't have a like term. 7a cubed doesn't have a like term either. So our final answer is simply 9a minus 4a squared minus 7a cubed. We can't simplify this any further. So 9a minus 4a squared minus 7a cubed is the result of subtracting these two polynomials together. Okay, let me box that for you. And let's move on to the next example now. So in this example, we got 14a plus 12a cubed plus 17a to the power of 4 plus 15 minus 5a cubed. So this is polynomial number 1. Polynomial number 1. And this is polynomial number 2. This is just a little bit of a bigger polynomial. So this is just a simple addition question. So we don't need to, we just simply drop the brackets. So 14 plus 12a cubed plus 17a to the power of 4 plus 15. And we have to add everything inside the bracket. So if we're adding, for example, we added plus 17a4, a to the power of 4 plus 15, and we're doing plus negative 5a cubed. Remember, plus a negative number is just simply minus that number. So let's rewrite this now. So it's going to be 14 plus 12a cubed plus 17a to the power of 4 plus 15. I hope I'm writing neatly. I'll try to write more neatly. And then we got minus 5a to the 5a cubed. Okay, I'll try to write more neatly now. I'm being a little sloppy. Okay, so now we remove the brackets. Now we collect all the like terms. So 12a cubed is a like term with 5a cubed, right? Because the same variable reaches the same exponent of 3. So 12a cubed minus 5a cubed is equal to 7a cubed, because if we subtract the coefficients together, 12 minus 5 is equal to 7. Then we have to include the variable in the coefficient. So we took care of these two. Now, 14 and 15 are also like terms, right? Of course they are. 14 plus 15 is equal to 29. Try to write that more. That's a 3, by the way. Plus 29. And then is there another like term? No, there's no other like term because 17a to the power of 4 doesn't have a like term. These ones are already taken care of. So we only have 17a to the power of 4 left. So this is your final answer to the question of when we add these two polynomials together. Okay, let's do one more example, and like I said, this one's going to consist of more than two polynomials. So we're subtracting this first polynomial, polynomial 1, with these two polynomials. So the first thing we need to do is flip the signs of both of these polynomials, what's inside of these brackets, create two polynomials, create two newly flipped polynomials, and we're going to add these newly flipped polynomials with the first polynomial, okay? I know that sounds a little intense, but let me break it down. So, okay, so let me draw an arrow here for you. Flip the signs of this polynomial. Okay? So if we flip the signs of 6x minus 5x squared plus 4, we get negative 6x plus 5x squared, right, minus 4. Now flip the signs of this polynomial now. Of the second polynomial, we get negative 5x to the power of 5 minus 7x. So now we add these two polynomials with the first polynomial. So we get 12x to the power of 4 plus 3x to the power of 5 plus 3x squared Okay, let's include the brackets in this step. Plus negative 6x, the new polynomial, plus negative 6x, plus 5x squared, minus 4. So we're adding the newly flipped polynomial to the original polynomial, and then finally we're adding this newly flipped polynomial that to the to the to the two polynomials. So we get plus negative 5x to the power of 5 minus 7x. Now we can drop the brackets, keeping in mind that when we're adding a negative number, like I said, we're simply subtracting that number. I'll show you what I mean. So we got 12x to the power of 4, just rewriting the first one with the drop brackets, plus 3x to the power of 5, plus 3x squared, plus negative 6x, plus 5x squared, plus negative 4. And then finally plus negative 5x to the power of 5. I know this is a little messy, I apologize. It's a pretty big question. And then finally plus negative 7x. Remember what I said, a plus and plus a negative number is simply subtracting it. So we got, let's rewrite it now, we got 12x to the power of 4 plus 3x to the power of 5 plus 3x squared minus 6x, right, because plus and negative is equal to just a subtraction, plus 5x squared minus 4, right, minus 5x to the power of 5 minus 7x. Okay, now we collect all the like terms, so 12x to the power of 4, does that have any like terms? I don't think so, so that's by itself. So let's rewrite 12x to the power of 4. 3x to the power of 5, does that have any like terms? Let's see. Yes, it does. So 3x and 5, 3x to the power of 5, and negative 5x to the power of 5 are like terms. So 3x to the power of 5 minus 5x to the power of 5 is equal to negative 2x to the power of 5. Okay. Does 3x squared have any like terms? Of course it does. It's like terms with 5x squared. So again, we're adding the coefficients of each term. So 3 plus 5 is equal to 8. And then, of course, the x squared. Negative 6x is a like term with negative 7x. So negative 6x minus 7x is equal to negative 13x. And then finally, negative 4, which doesn't have any like terms. So this is our final answer. I hope you guys found that helpful. Again, if you have any questions, please feel free to leave it in the chat, and I'd be very happy to answer. Thank you so much for watching. Take care.